We're still using our kinematic equations of motion, to answer some questions. Just a reminder, remember the symbols: v subscript I, initial velocity; v subscript f, final velocity; acceleration, distance and time; and our units: velocity meters per second, acceleration meters per second squared. Remember too, these equations, just remember them. Three, remember that when we answer our questions, when we solve our problem, we're going to use guess. In this case, the guess works really well with this. So we're looking at number 4a, and we've got an excited gunman. He fires a bullet into the air. You can see it's quite a long bullet. He fires it into the air. We're ignoring air friction. What's the maximum height this bullet reaches? So say from the ground, imagining he's firing from the ground, how high will it reach? How high will it go before it starts coming down again? If its initial velocity is 230 meters per second. So how high does it go? This is a very common question, and we just need to be thinking clearly about this. We want to know how high it goes. What's the height that it reaches? So let's check our guess. Let's do our guess. What are we given? We're given an initial velocity of 230 meters per second. How high does it go? It's shot out against gravity. It's slowing down as it gets higher until it reaches a point, a maximum height, when the velocity is now 0, then it starts falling down again. So when we say how high does it reach, we're saying how high is it when the velocity is dropped from 230 down to 0. So we're going to say the final velocity at the top of its trajectory is 0 meters per second. What else are we given? We'll be given that the acceleration due to gravity is 10 meters per second squared. And if this is 230 meters per second in a positive direction, acceleration in the other direction has then got to be negative. If 230 meters per second, we're considering that the positive direction, the acceleration is in the opposite direction, so the acceleration has got to be negative. So you've got a negative 10 meters per second squared. So you've got to identify clearly the direction of the velocity. We're going to say it's positive 230 meters per second. The acceleration is in the opposite direction, so if that's positive, this is negative. So there's our givens. We're given an initial velocity, final velocity, and acceleration. What's our unknown? We're asked to find the maximum height. So what's an equation which ties those three together, those four things together? V final squared is equal to V initial squared plus 2AD. Let's substitute into our equation. Final velocity is 0, initial velocity 230 squared, plus 2 times acceleration. Acceleration was negative 10, 2 times negative 10 times the distance. Note that the acceleration is negative, so we've got to multiply 2 times a times d, 2 times negative 10 times d. And we can solve that equation, and we can end up with the distance is equal to 2,645 units again, meters. So that's how high it would fire. Now some of you have seen Mythbusters where they actually did this experiment, and they found that many times actually it didn't go straight up and straight down, it went somewhere quite a way off, which is why you mustn't do this at home. because it's not going to come straight down and hit you in the head. It might end up somewhere a little bit over there and kill your neighbour's cat or something, so don't do that. So that's using our kinematic equations and guess to solve our problem there. And part B, how long does it take to reach this height? So let's use our guess again. We've got initial velocity equals 230 meters per second. We've got final velocity when it reaches the top and start just at the point it stops, just before it starts falling back, and final velocity is 0. The acceleration is negative 10 meters per second squared. And we want to find our unknown, is we want to know how long it takes. So what's an equation which ties just those four things together? V final equals V initial plus AT. Substitute, V final 0 is equal to 230 plus negative 10, our acceleration was negative 10, times t. Solve, t is equal to 23 seconds. Okay, that's simply solved, as you can see, using our kinematic equations.